Now what I'd like to do is demonstrate how to use Stata to do a correlational analysis. And what I'm going to use is a data set consisting of high school grades for a group of 105 students called the grades data. And so I'm going to open that data and we'll just browse that a little bit. So we have some categorical data such as gender and ethnicity. And then we have GPA, Quiz 1, Final, and Total, which are considered interval level data, although GPA is really technically an ordinal data, but we're going to treat it individually as interval data for this particular analysis. So if I want to do just a bivariate correlation where I correlate two variables, I can go to Statistics, Summary, and Tables, and Summary and Descriptive Statistics, and then I can go to Pairwise Correlations and just pick any two variables. So let's just say I want to pick, I want to correlate final and total. So I can do that. I want to print the number of observations for each variable and the significance level. And then I can click on OK and toggle to my results screen. And you can see that I have the correlations are the top result. And of course, final and final, that's going to be perfectly correlated, and there's 105 observations. Total and final, the correlation is 0.885. It's highly significant. P is less than 0.001. And there's 105 observations. Now, a lot of times what we like to also do is correlate more than two variables. And we can do that by going to Statistics, Summary, and Tables, and then Pairwise Correlations again. And let's just say this time we want to correlate gender, Quiz 1, Final, and Total. So we're going to have a correlation matrix consisting of 4 different variables. And we have the number of observations for each entry, and then we have the significance level that will be printed for each variable. So then again we can go OK, and this is our correlation matrix. And so you can see that the correlation between gender and Quiz 1 is 0.1276, but it's negative. And all that means is that one of our variables, one category, male and female, in the way that they're coded, males coded 1, I believe, in this data set, and females coded 2. So let's just see how that is. If we go to the variable manager, and we go to gender, and let's just see how that's coded. So female is coded 1 and male is coded 2. So what that basically means is that if you were to calculate the means, is that males have a higher Quiz 1 score than females, although this correlation is not significant. We can interpret that the same way with the final and the same way with the total scores. But none of these correlations are significant, and these correlations are small. Then we could look at let's look at final and Quiz 1. That correlation is 0.5351. It's highly significant. The correlation between total and Quiz 1 is highly significant, 0.8164. And of course, from our previous analysis, we can see that the correlation between total and final is 0.8815. So how do we interpret these correlation coefficients? Well, from your PowerPoint, we can see that correlations that are less than 0.20 are very small, slight, negligible. 0.20 to 0.40 are small relationships. Then between 0.40 and 0.70, those are moderate relationships. And then we get into stronger high relationships when correlations exceed 0.70. So I hope this video has helped. And if you have questions, please let me know.